So bisection method. All right, and the prefix bi, refers to two, like bicycle, right? Two wheels. So anyways, what we're going to do is basically to bisect something means to cut it in half, or yeah, basically to cut it in half. So this method allows us to locate a zero, so where the function is equal to 0, more accurately, okay? Than just kind of like saying, okay, it's got to be there, because that's basically all the intermediate value theorem does, right? That's as far as its extent reaches, is saying, okay, on this interval there must be a 0. But with our bisection method, which I'll show you in a minute, that can allow us to use the intermediate value theorem, like the concepts behind it and the principles, to locate that zero more accurately. We can zone in on a smaller and smaller interval. Okay, so what we're going to do is basically, so I'll show you an example, okay? So here's an example. So we're going to locate 0 of the following function, f of x equals cosine squared x minus 2 times sine x over 4 on the interval 0, 2. And this is our x interval for x, right? Okay. Alright, so we have this 0, 2 given as our interval. And what we're going to do is find the value of the function at 0. So this is like our a, right? And this is our b. So we're going to find f of a and then f of b and go from there, okay? So f of 0 is equal to 1, which is greater than 0, right? So that's a positive value. And then we have our f of 2, okay? We'll calculate that. F of 2, and then when you plug that in, basically all you have to do is plug a 2 in for the x spot. And when you plug that into a scientific calculator, all you get is a negative 0.786, which is definitely less than 0, right? So that's a negative value. So let's draw this on a graph, because we're going to need it. So I'll show you what's really going on in the bisection method. So let's say we have, so 0 and 2, right? So 0, here's 0, here's 1, and here's 2. Okay, 1 and 2. Okay, so the first thing, so f of 0 was equal to 1. So here's a 1, that's a positive 1, and I'll draw a negative 1 down here. Negative 1. Okay, so 0 was right there. So this is our f of 0. And then f of 2 turned out to be something that was like almost negative 3/4, right? Or a little more than negative 3/4. So this is our f of 2. Okay? So then that means that on this interval, we must have a 0, right? Because we know that f of x is going to be continuous because cosine and sine are continuous functions. So anyway, so this graph must do something, and there's a 0 somewhere. But our goal is to find where it crosses the x-axis. Where is that 0? And so we'll continue on, and this is how we're going to do it. So now what I'm going to do, so this is, we found those two endpoints. Okay, that's great, but we can't just like guess where the 0 is, right? We want to find it more accurately. So on this interval 0 to 2, we're going to pick the midpoint. Okay, so the midpoint in this case would be x equals 1. So the mid x point, that's what I mean. So we're going to plug in that mid x point, so this one here, we're plugging this guy in to find out where is it. Is it above the x-axis or is it below the x-axis? Okay, so let's do so. If we plug in a 1 for our function, then it's going to turn out to be a negative 0.203, okay, and that is definitely less than 0. So that means it lies about, I don't know, maybe negative 5th. Okay, so down here, all right? So see how now if we were to draw a function, okay, and we want to hit all these points, all right? So see on this second half here, it doesn't necessarily have to cross the x-axis, right? Unless we actually have to go up like that or something. But it doesn't have to. To get from f of 1 to f of 2, you don't need to cross the x-axis. So what we can do is actually rule out this section here, okay? And that's what we're going to do. Alright, so that means that this section, we don't really care about that at all, because it doesn't have to cross the x-axis. See how now from 0 to 1, so now let's look at the interval from 0 to 1, then there has to be a 0 in there, because one of the values is positive, the f of 0 is positive, and the f of 1 is negative. So here I'll put f of 1 is negative. Okay? We're straight across there. Alright, so now we're narrowed down to this interval. X equals 0 to x equals 1. So now, we'll keep going, a couple more steps here. So now we have to find the midpoint, the mid-x point, so that would be our 1/2, okay? So now we're going to plug in, so midpoint of 0 to 1 is x equals 1/2, and then f of 1/2, if we were to plug that in, then we would get 0.521, which is greater than 0, right? So that's a positive value. So here it's like almost half, or it's a little bit above half, okay? So here's our f of 1/2, okay? So now, between these two mini intervals here, so between here and here and here are half intervals. The first one, those are both positive values, right? So that doesn't tell us anything. It doesn't have to go down, touch the x-axis, and then come back up. But this second one here, number 2, this one does, because f of 1/2 is positive, as we just found, and f of 1 is negative, so it does have to cross there. So this is the one we're going to go with. We're going to rule out this one here. We don't need that interval. And now we're down to 1/2 to 1. So it has to be somewhere in here, the 0. It has to be lurking somewhere in there. Okay? So I'll continue this on the next slide, and we'll go one more step. Alright, so here's our picture again. We have something like this. Alright, so we narrowed it down basically to, so here's 1, here's 2, 0, 1, 2, and here was 1/2. So we're down to this. Okay? So this interval in there, here's a 1, here's a negative 1, alright? And then 1/2 was like 0.5 something, and f of 1 was negative 0.2 something. Okay, so we're down in here, we're looking in this interval, alright? So now we're 1/2, 1, and we'll go one more step, like I said, so we're going to find the midpoint, the mid-x point, so that would be a 3 over 4, right? So if we find f of 3 over 4, this is going to turn out to be a positive 0.163, okay? And that, if we graph it, so here's 3 over 4, okay? And then 0.163 is about right there. So again, this is a positive value. So what we want to pick is the interval, the like survivor, the interval that we're going to keep is the one that includes our f of 3 over 4. So 3 over 4, which it turned out to be positive, and the negative value. So that would be our f of 1, okay? So this one here, this positive one and the other positive one, the f of 1/2 is above the x-axis, and f of 3/4 is above the x-axis, but f of 1, I'll just write over the 0 here, f of 1 is below, okay? So we don't want to make an interval out of the 2 above, because that doesn't tell us anything about zeros. So we're going to cross this guy out, okay, crossing that one out, and we're left with 3 over 4 to 1. So that's a pretty accurate estimation there, or pinpoint of where the 0 lies, okay? So on this interval, we can say that f of x has a 0 at x equals c. We still don't know the exact value. I mean, you can keep going and bisecting the intervals here, but we don't have all day, so usually what I do is just go as far as the problem tells you to. But anyways, f of x has a 0 at some point, some x value, with c being between 3 over 4 and 1. So it can't be the endpoints, even though I wrote it in the interval here. It cannot be the endpoints because we found that f of 3/4 is 0.163, and we found that f of 1 is like negative 0.203. Which those are definitely not equal to 0. Okay? Alright, so that pretty much does it for this video about the intermediate value theorem. I hope that helped, and good luck on the homework.